Apologies for the fuzziness of the font here. The Smart Notebook software, I think, might need to be upgraded. The screen capture tool is not as strong as it used to be. So this says use a right triangle. Now they're just straight up telling you. Okay, so in a few of the previous examples, like so, we walked through like the thought process or the decision process behind should I use a unit circle or the right triangle to do this problem. Same thing here. This you could have done it either way. This you could have done it either way. Okay, this you could only use right triangles for. This one's telling you use a right triangle to do this problem. And I hope it's obvious, because if I rewrite this as arc cosine, okay, what pi value has an x coordinate of 9x? That's not something we see on the unit circle, right? Like we said before, like we said in well, I guess I got rid of it. But the list of x coordinates is 0, 1/2, radical 2/2, radical 3/2, and 1. That's it. So when we're outside of that list, we're going to have to use the right triangle. So I'm going to draw myself a right triangle here as quickly as possible. There we go. And now what this is saying, again, stop me if you've heard this before, if you've watched the other videos up to this point. This problem will be done when we have an expression for the tangent of the output of this. And the output from this expression is an angle. Do I need to know what the measure of that angle is? No, I don't. Okay. I just need to find the tangent of that angle. So here's my angle, theta. All right. I'm never going to go to the calculator to find the value of this. In fact, in this problem, I won't be able to. Okay. But what this problem is saying is that this angle has a cosine value of 9x. And if we're using a right triangle, that means 9x, as awkward as it sounds, that's an adjacent over hypotenuse ratio. Okay. So, because the input to an inverse function is either a ratio of sides or a coordinate. That's certainly not a coordinate. So it has to be the ratio of sides. So it might make a little bit more sense, instead of writing it as 9x, as saying it's the arc cosine of 9x over 1. Now it's the adjacent side to said angle over the hypotenuse. So the hypotenuse is 1 and the adjacent side is 9x. And before you start saying, wow, this can't be greater than that, x, it doesn't say that x has to be an integer, right? So really what we're saying here is x has to be less than 1/9, right? Because then it has to be less, the overall value has to be less than 1. So this is 9x. We got to go with that. And now, again, the final answer to this problem is the tangent of theta. And the tangent of theta is the ratio of the opposite side over the adjacent side. The tricky part is going to be finding an expression for this opposite side. That's where the work's really going to come in. So again, I'm going to use P, because P for opposite, I'm not going to use O. So I can quote unquote solve for P using the Pythagorean theorem, right? 9x quantity squared, the parentheses are key here, because if you write this, that's only x squared, right? We have to square this whole side, so we need the parentheses around it. 9x squared plus p squared equals 1 squared. When we square 9x, we get 81x squared plus p squared equals 1. This is already shaping up to be one of those unsatisfying problems where we don't get a number for our answer, right? Because we're never going to be solving for x here. So we're going to take this quantity and subtract it to the other side so we can isolate the variable we're actually solving for, which is p. And then we're going to take the square root of both sides. Now, when we take the square root of this and this, you cannot take the square root of a difference. Okay. Don't tell me that this is 1 minus 9x, right? It doesn't work that way. I think we've talked about this before, but in case in case you need another example, if you did the square root of 16 minus 9, that's the square root of 7, right? Because 16 minus 9 is 7. It's not this. It's not 4 minus 3. I don't get to take the square root of 6 and 9 separately and then subtract them and say that it's equal to 1. The math doesn't support it, right? This is the correct answer. This is not. So we don't get to do that when there's variables involved. Like I said, it's one of those unsatisfying answers where we have to say, this is what P represents. Okay? So, unfortunately, like I said, unsatisfying. We're going to say this is a square root of 1 minus 81 x squared. So what is the tangent of that value of theta? It is this value. Sorry, I'm going to have to erase this. The tangent of theta is the opposite side, which is the square root of 1 minus 81x squared over the adjacent side, which is 9x, which is a horrible looking expression, but it is what it is, right? I wish there was a better way to say it.